Okay, we're gonna go over the Sorting Earth's Materials lab. And I'm gonna kind of walk you through it. I have a printed out version of the student sheet here. And I will be going through each part of the lab with you so you can follow along since you are at home or miss the lab for the day and need to make it up. So, what we need is a scale, some sort of calculator. We need what's called a graduated cylinder. It has numbers on it to measure the number of milliliters on it. And some water. I typically like to use a funnel to help keep it cleaner. We then have our samples up here, which include iron, zinc, tin, aluminum, copper, and then 3 different types of rock, which are basalt, granite, and slate. So let's go ahead and read the introduction of Sorting Earth's Materials. Part 1, Introduction. Scientists have made calculations to determine the densities of various Earth layers. In this activity, you will measure common materials and see if you can correctly match them to the values scientists have calculated for the layers of the Earth. So our objectives today are to practice measuring mass, to practice measuring volume, and to calculate density. After we calculate density, we are going to be analyzing which of these objects goes in which layer, and I'll show you how to do that when we get to that part. So, to get the mass, it's simple. You turn the scale on. We have nice digital scales, and you want to make sure it's 0 and at the right units, which is grams. Once you got that, you're ready to go to take your mass. So let's go ahead and take the mass numbers of all of ours here. So iron, which is the first example. This is iron. It's pretty heavy. So let's go ahead at 0, so we're good to place iron on there to get our mass. And the mass of this iron sample is 41 grams. So that's what you write here, 41 grams. Now we're gonna take the mass of zinc. Take that off, went to 0, so we're good to go on the next one. Here is our zinc, you can see that. Place it on our scale. And this sample of zinc doesn't want to stay in, we'll go with 7 grams. 7 grams. So our mass of zinc is 7 grams. Go ahead and take that off. Next, we are going to do tin. So, mass in grams of tin. This is tin. 0. 7 grams again. So, the 2 right there are 7 grams. You want to take that off? So tin is 7 grams. Now we're going to go ahead and do aluminum. Aluminum is 15 grams. Perfect. So we've already gotten 4 of them here. We're going to take aluminum off the digital scale. Make sure it goes back to 0. We're good to go for the next one. So our last metal piece is copper. Let's go ahead and take the mass of copper. Copper is 51 grams. You see that right here. So just to review, hopefully you can see that okay. Our mass of iron, zinc, tin, aluminum, copper are as follows. If you need more time to write it down, you can pause the video. All right, so now we are going to calculate volume. So we're done. Oh wait, just kidding. We need to do the mass of the rocks. We're gonna start with basalt, which is a gray rock. This is basalt. We're going to take the mass of this sample, and it is 20
I
it's moving. It's been on 23 more, so we're gonna go with 23 grams. Okay, it's back to 0, so we're ready to go to granite. Here's our sample of granite. Our sample of granite is 27 grams. Our final sample, which is slate, is up next. Slate is typically in it has thin layers and kind of breaks off. So this is what slate looks like. We're ready to go with the 0, so let's go ahead and place it on the scale. And our slate is 7 grams. Okay, so we are done with taking the mass samples of all of our items. So I'm going to go ahead and remove the scale, and I'll show you what this looks like a little closer. You can pause it if you need to. All right, so we're going to talk about how to do the volume here. And I'm going to do that by drawing a picture. So to calculate volume, we use what is called the volume displacement method. And it's really simple. There's essentially 3 steps to it. So the first step is you're going to take your graduated cylinder, which has the measurements on the side, and you're going to fill it up about halfway. It really doesn't matter where you fill it up, it just has to be enough for your object to be covered in the water. So step 1, and we're going to call this the start volume. So to take your starting volume, you're going to fill up your graduated cylinder about halfway. So fill it up with water about halfway, okay? So that's what I'm gonna do here really quickly. I'm gonna put my funnel on my graduated cylinder, and I'm gonna fill it up halfway, or approximately. It really doesn't matter because we're gonna be reading the lines. Oh, I think that's too much, so we're gonna take some of that out. Yeah, we'll call that good. Okay, so I filled up my graduated cylinder. Okay, the second step is you need to calculate the end volume, and let me explain what that means. So once you've gotten to this step, you're going to place your object into the graduated cylinder with the water. So the water has to be enough to cover your object. So you slide your object in, and that water level is going to increase because of that object that's in there, okay? So after you've placed the object in, you can then take your second measurement, which is your end volume. So we put our object in it. There's our little object in our cylinder, and the water goes up, okay? You take 2 measurements. I like to call it the start volume and the end volume. The end volume is with the object and water, while the start volume is just the water. So that, when you get to step 3, all you have to do is subtract. You're going to calculate. You're going to take the end volume and subtract the start volume, and that will, whatever is left over from subtracting those, will give you the volume of your object. That is the volume displacement method. So if you get a little lost as to what we're doing, you can refer back to this part of the video. We're simply using the displacement of water to help us calculate the volume. So let's get started. What I'm going to do on here is I'm going to write end volume minus start volume to remind us how we are calculating that. Okay, so I'm going to reset this and we are going to start taking our measurements. We're going to start off with iron. So I'm going to fill this up about halfway. And I went to about 49 milliliters. So our start volume, see how we're going to be putting two numbers here? The start volume was 49 milliliters. Okay. Now we're going to get our end volume, so we could do end volume minus start volume to get our object volume. So now I'm going to take the iron, because that's what we're doing, and I'm going to place it in, and we're going to take our second measurement. Okay, so I'm going to look at the numbers here, and it went to about 54 milliliters. So now what we're doing is we're subtracting end volume minus start volume. So it's 54 minus 49, and that equals 5. So thus, our volume of the object is 5 milliliters based on our calculations. Okay, let's go ahead and do that really quickly for the rest of our objects. Okay, we did iron. Let's do zinc. Okay, that's on the bottom. So, our starting volume, if we look up here, is 42 milliliters. Let's go ahead and add our zinc. And it has gone up to 43 milliliters. So that means 43 minus 42 equals 1 milliliter. The 1 milliliter is the volume of our object according to our calculations. So we're going to go to tin. My guess is tin's fairly the same size, so it's probably going to be about the same as the other one, but we're going to calculate it just in case we're wrong. Added a little more water that time, but that's okay. So I'll read the side up, the numbers. 5, 66, 7, 68, 6, 7, 8, 9. We're going to go 69 milliliters. Okay. Now we're going to add our tin into the graduated cylinder. There we go. The 69 went up to 70. So yep, we were right, because 70 minus 69 equals 1 milliliter. So those two objects had the same exact volume. Now we're going to calculate aluminum. Let's reset our experiment. Here's our piece of aluminum. Let's pour some water back into our cylinder. There we go. We're going to get our start volume by reading up the sides how much water we added. 1, 2, it's about 63 milliliters. All right, now all that's left to do is to add our aluminum into our graduated cylinder. And that brings us up to 68 milliliters. So 68 minus 63 is, you guessed it, 5 milliliter volume. We only have one more metal piece to go, so let's set it up and get ready. Okay, we're ready. Let's take our starting volume for the copper. And it is 46 milliliters, according to the numbers on the side. If you're wondering why I'm writing the starting volume after, that's simply so we don't get a negative number, because we do end volume minus start volume. Okay, copper it is. In the water we go. Okay, time to take our end volume. We go up, it's about 51, 52. I think, let me double check. Yeah, it's 52. So we do 52 minus 46 is 6 milliliters. So our volume of this object is about 6 milliliters. Okay, now it is time to do the volume for our rocks. In order to do the rocks, you'll notice that the rocks are a little bit bigger in size than or weirdly shaped at least, than our other samples. So I'm gonna switch this graduated cylinder out for a larger graduated cylinder, because everything bigger is better. Just kidding. So I'm gonna fill this up with some water. We're gonna do the same exact thing that we did, just with a larger beaker so that it fits inside. So we're gonna start with basalt. When we are done with the basalt rocks, I'll show you the numbers at the end. Okay, we're gonna put it about there. So our start volume for basalt is 72 milliliters. We're gonna do the same exact thing that we did for the other volumes, okay? Now all we need to do, you guessed it, add our basalt rock sample into the graduated cylinder. Boom. And that brings us to about 82 milliliters. Okay, now we gotta get the rock out so we can do our next one. Okay, we're done with basalt. 82 minus 72 is 10. So our approximate volume of basalt was 10 milliliters. Let's set it up so we can do granite next. Here is our sample of granite. Before we plop this in, we need to look at the starting volume of water so we can see the change. And this is going to be about 70, no, that's 80, 82 milliliters. Okay, let's plop our granite in and see what our end volume is. Ooh, that was an error. So we're actually gonna have to restart this because we lost water. Sometimes I get a little hasty and add it in sooner than I should. Okay, let's redo the start volume. It's plenty. So this number is gonna be changing. So let's take a reading. We got, instead of 82, we went to 84 milliliters. So just set this to 84 instead of 82. And this time, let's not make a big splash. So we're gonna tilt it and slide it in as slowly as we can. Maybe, there we go, much better. Okay, we'll read the sides here. It's gone up to 94 milliliters. we got another 10 mil. So 94 minus 84 is 10 milliliters. Who would have guessed? I didn't know. So we got one more. So we're going to reset this so we can do our slate reading. This one will be different in volume. It's flat. One out. Okay. So let's fill this up. I think that's plenty. So our starting volume is 52, 4. I think it's 56. Let me double check. It's 55 milliliters. Okay, final sample that we are going to be measuring, our slate. So let's plop that in, try not to make a splash like we did last time. Oh, perfect, beautiful. Okay, our rock sample is now in there, so we can take our end volume. And that is 58 milliliters. So now we just calculate simply by subtracting end volume to start volume. So we have 58 minus 55, which gives us 3 milliliters. So now we have, I'm gonna get a highlighter out. We have all our masses and we have all our object volumes. I'm gonna highlight those so you know what we are focusing on. Let's see if I have another highlight color. I don't believe I do. I used to. Okay, so we can underline those with red. These are our mass numbers that we are going to be using. Okay, the remainder of our work is going to be simple calculations. When I say simple, it's going to have to do with density. Now we've learned in class that density, I'm going to use this to write us some notes. Density, we define density as the amount of matter in an object in a given space. Okay, so let's break this definition down. We can actually get a formula from this definition because it's talking about two things in density. Mass, which is the amount of matter, that's mass, and a given space is volume. Which makes sense because on our worksheet we were measuring mass and volume. So scientists have boiled density down to a simple formula, which equals density equals mass divided by the volume. Mass divided by the volume. That stands for division sign. So knowing that, let's spin this a little bit so you can see it. Our mass divided by our volume. We are then going to calculate our density by doing mass divided by volume. So the mass is going to be in the red sections, and the volume is going to be the highlighted yellow sections. Let's get down to business. So mass divided by volume, we're going to do 41 divided by 5, which equals 41 divided by 5 equals 8.2. So that means our density is 8.2, and our units have been given here because we're dividing mass by volume. It's grams per milliliter. That is our density. Let's go ahead and calculate zinc. If you want at this point, you can go ahead and calculate all of them yourself. In fact, actually, that's what I'm going to have you do. So I'll do one more example with you, and then you calculate the remainder of your densities. And then I'll show you what you need to do for the remainder of the work. So zinc, we need to take our mass, which is 7, divided by 1. 7 divided by 1, anything divided by 1 is the same number. So we have 7, and we have grams per milliliter. Okay? Go ahead and calculate the remainder of these from what we went through. If you need to refer back to this, you can, or write down the density equals mass divided by volume. That would be of great help to you. So now, once you've gotten your density, you are going to be comparing it to, I'm going to move my paper up a little bit, this chart down here. This chart is showing the different layers of the Earth, even including the ocean and atmosphere, and their approximate densities that scientists have measured and calculated. So you're going to compare, so I'll do iron with you, for example. So you're going to look at your density for each of the objects. So the density here is 8.2. So now we're going to see where 8.2 fits down here in this scale. Well, if we look at this, 8.2 is going to be closely matched to, it's just barely under outer core. It's closer to outer core than it is mantle, because 8.2 is closer to 9. So we're going to say that the iron is probably most likely found in the outer core, which makes sense from what we have learned. Okay, so all you do, take a look at your density, your number of density, and you see where this matches. So for example, I'll do zinc with you, our last example. Zinc is 7 grams per milliliter. So we come down here and look. Well, the ending of the mantle is about 5.7, which is approximately 6, and the outer core start is 9. So 7 is closer to 6 than it is to 9. So I'm going to say it's probably going to be the outer part of the mantle, or the inner part. So I'm going to go with mantle on this second one. You find where that density closely matches. Then, what you're going to do to finish off this assignment, you'll finish calculating densities, finish matching the layers. Don't forget to do this part, the average density of basalt, granite, and slate. So you're going to be calculating the average density for those objects and putting the answer here. Okay? You will need the average density in order to do these two questions below. So to get the average density, you just simply add up all 3 of the rock densities and divide it by 3. And it's written there just in case you forget. Okay, so go ahead and do the densities, the earth layers, the average density, and then answer those 2 questions, and you're ready to submit. And I will bring this up closer for you. Hopefully you'll be able to see that. I'll also add a picture on, well, maybe not. I want you to follow the video. But if there's something you can't see, please let me know. I did talk about them in the video, so hopefully that works. Let me hop up there so I can see the top of the camera and show you this. Make sure it's showing clearly. Okay, so these are the results of what we took. You can pause it there if you need it to. And hopefully you enjoyed this little demonstration. Thanks, guys.